Hello everyone. The chapter which we are discussing is chapter 4 of class 10 physics. And the part of the chapter which we are discussing is moment of a force and equilibrium. Today, in this part of the chapter, we are going to discuss couple with examples, moment of couple, equilibrium of bodies, that is static equilibrium with examples and dynamic equilibrium with examples, conditions for equilibrium and principle of moments. So let's start with our first topic, that is couple. Here we have a few pictures. In the first one we have a tap. In the second figure one is trying to open a lock. In the third picture a person is trying to open the lid of a bottle. In next picture, a person is trying to open a jar, and here a person is driving a car and applying forces on steering wheel. Now, if this person who is opening the lid of this bottle tries to open this by applying one force only here and no any other force is applied, will he be able to open this lid? No. If a person tries to open this jar by applying one force only here and no other force is applied, he will not be able to open this jar. If we try to open a lock by applying one force at the one end of the key only, we will not be able to open the lock. That means for doing all this, two forces are required. So, a pair of two equal and opposite parallel forces not acting along the same line form a couple. Here is a diagram. This is a force acting upward and same magnitude of force is acting downward. This is the distance, perpendicular distance between two forces. The perpendicular distance between two forces is also known as couple arm. Now, why we say that this is a pair of two equal and opposite forces not acting along the same line? Because if two equal and opposite forces will act along the same line, they will cancel each other's effect. The way it happens in tug of war. Here, equal and opposite forces are applied but on the same line of action, so there will be no any result. No body will rotate. No turning effect will be produced. In fact, two equal and opposite forces will balance each other. They will cancel each other because they are acting along same line of action, and there will be no any net force acting on the body. Now, the next topic is moment of a couple. The moment of a couple is defined as the product of either force. As we are talking about two forces in this, two equal and opposite forces, so we can take either force, any one of them, and perpendicular distance between two forces. And we all know that perpendicular distance between two forces is known as couple arm. Now we'll try to find out the formula for couple mathematically. Here we have a diagram. This is a force F acting downwards, and this is the same magnitude of force acting upwards. AB is the perpendicular distance between two forces, which is also known as couple arm. Now, we will be using the formula to find out the torque about point O here. This is the point O. Moment of force F at end A. Moment of force F at end A will be force F into perpendicular distance OA. So it will be F into OA. As it is trying to turn the body in anti-clockwise direction, we have written anti-clockwise here. Next, we'll find out the moment of force F at the end B. It will be magnitude of the force F, that is F only, and perpendicular distance OB. So it will be F into OB. Now, what will be the total moment of couple? That is total moment of forces about point O. For that, we'll add these two. We'll add F into OA plus F into OB. F will come out as it is common. So we'll be left with F into OA plus OB, which is F into AB, because OA plus OB makes AB. Now AB is the perpendicular distance between two forces, that is AB is the couple arm. So the total moment of couple will be F into D, that is product of either of the force and couple arm. The next topic is equilibrium of bodies. Let's take an example to explain equilibrium. Here we have a book lying on a table. The weight of the book is acting vertically downward and normal reaction by the table surface is acting upward. We can say that there are two forces acting on this body in different directions, but we also notice one thing: these two forces acting on the body are not able to make any change in its state. The body is at rest even when two forces are acting on it. So, when a number of forces acting on a body produce no change in its state of rest or of linear or rotational motion, the body is said to be in equilibrium. Equilibrium is of two types: static equilibrium and dynamic equilibrium. Let us first talk about static equilibrium. Again, we have a book lying on a table. There are two forces acting on the book, but they are not able to produce any change in its state of rest. So the body is in static equilibrium. In the next example, we have a beam balance. When two equal weights will be there on each pan, this beam balance will not rotate towards any side. It will be at rest. So forces are acting on it, but they are not able to produce any change in its state of rest. We can say that this beam balance is in state of static equilibrium. So, when a body remains in the state of rest under the influence of several forces, the body is in static equilibrium. Next is dynamic equilibrium. Here, a raindrop is falling. And we have one more example: an aeroplane flying at a constant height. When a raindrop is falling down, its weight is acting vertically downward, buoyancy is acting upwards, and so many other forces are acting on it. But still, a raindrop falls down with a constant velocity. And in case of an aeroplane flying at a constant height, the weight of the aeroplane is acting vertically downward and the upthrust or buoyancy is acting vertically upwards, and so many other forces are acting on this plane, but still this plane manages to fly at a constant height. So we can say that these both are in state of dynamic equilibrium. Number of forces acting on them are not able to produce any change in their state of motion. Right? So when a body remains in the same state of motion, translational or rotational, under the influence of several forces, the body is said to be in dynamic equilibrium. Now we'll discuss the conditions for equilibrium. The first condition for equilibrium is the resultant of all the forces acting on the body should be zero. And the second condition is the algebraic sum of moments of all the forces acting on the body about the point of rotation should be zero. That is, the sum of the anticlockwise moment about the axis of rotation must be equal to the sum of the clockwise moment about the same axis. The next topic is principle of moments. According to the principle of moments, in equilibrium, sum of the anticlockwise moments is equal to the sum of the clockwise moments. A physical balance or a beam balance works on the principle of moments. When the same weights will be there in each pan of this physical balance, the anticlockwise moment will be equal to the clockwise moment, and this beam balance will not rotate and it will be in equilibrium. So that's all for our today's video. We will be discussing our next topics in our next videos. Thank you so much.